Hello folks, the Old Texan here. I'm going to invite y'all for a minute just to look over my shoulder and talk about some useful numbers. Now, there is no math. You don't need to grab a hold of anything. It's very simple, okay? Just 3, 4, and 5. And I tell you what I'm going to do. I'm going to take this column and I'm going to make a whole bunch more numbers right here below it. So I'm going to make 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. That's a good enough place to stop. Now on this column we're going to go 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. I think you see a pattern developing here. How about this one? Let's make this one 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Look at that. 3 went to 30, 4 went to 40, 5 went to 50. That's pretty interesting. Now what do those mean? Well, if we go back about 2,600 years ago, there was this pre-hippie dude, a Greek feller, that was into all kinds of weird stuff and living off land. Anyway, he left Greece and he went up to Italy and he started what he called a school. But we don't know a whole lot about it because he made everybody come to it sign the equivalent of what would be a non-disclosure agreement back then. And they call themselves philosophers, which the Greek word means seeker of knowledge. That's really about all we know about his school, other than they were into some weird foods and communal, like I said, pre-hippie stuff. But he was also pretty smart and really good with numbers. He was one of the people that supposedly figured out the circumference of the earth. And we're talking 2,600 years ago. There wasn't a whole lot of satellites up in the sky at that time. One of the other things he did was he got to messing around with triangles. And he figured out that there was a relationship on a right triangle. Now you might have heard of it. The fellow's name was Pythagorean. And he said that if you have a right triangle, which means a triangle that has a 90-degree corner on one side, that the relationship of the sides would be that if you took and you squared this number and you squared that number, it would equal that number squared. Yeah. Well, let's just try it. Remember how to square a number? You multiply it times itself. Well, 3 squared, 3 times 3 is 9. 4 squared, 4 times 4 is 16. And 5 squared, 5 times 5 is 25. So if I add 9 and 16, I'll be darned, it comes out 25. Ain't that weird? I'm not going to do all the rest of the numbers, but I'll guarantee you that if you sit there and you square 12, which would be 144, and 16, which I'm not going to do in my head, and 20, which would be 400, that it will work out that this number squared plus this number squared will equal that number squared. Guaranteed. You got that? You think you can remember that? 3, 4, 5. Really easy. 3, 4, 5. What does that mean? Well, since we're talking about triangles, how about I get out a triangle? And it's one that has a 90-degree angle on it. I'm just going to make some lines. I don't know how long they're going to be. They're going to be that long. And I said now that if A squared plus B squared is going to equal C squared down here somewhere. Well, now here's one of the other interesting things about that. That 3, 4, 5, it doesn't matter if you're using inches, centimeters, furlongs, nanometers, centimeters, light years, whatever you want to measure in, it doesn't matter. If you got 3 furlongs and 4 furlongs, then it's going to end up 5 furlongs across the other side. So let's just take this measuring stick here and let's go down. We'll use inches on this one. Okay. There's 3 inches is right there. If we go over on this side and do 4 inches right there. If I measure across here, that better be pretty darn close to 5 inches. And that's accurate within the width of this big marking pencil. So if I just take and draw a line right across there. Now, if I would have used centimeters, which this rule also happens to be in, it would have worked. I could have gone, well, let's see, how long did I make my line here? I could have gone 9. Kind of hard to do with that blankety blank camera in the way. I could have gone 9 over there and 12 over here. And this cross here should be about 15. That's pretty darn close to 15. Like I said, that's within the tolerance of the width of this big old marking thing. So now, I hope you understand the relationship between 3, 4, 5, and how you can take a multiple of 3, 6, 9, 12, 15, whatever, and a multiple of 4, 8, 12, 16, 20, and know what the distance between those should be. And later, I will show you some practical applications of it. Thank you, and that's it for the night for the Old Texan. Have a good one.